Next topic in our chemistry unit is entitled Clean Air. So, the first thing we need to know is what makes up the Earth's atmosphere, particularly interested in the layer of the atmosphere that we breathe, so air in other words. Now, the composition of air has remained roughly constant for the last 200 million years, and it's about 78% nitrogen, 21% oxygen, 1% noble gases, and less than 1% CO2. So if I were to put all of those into a nice pie chart for you, there you go. So as you can see, the atmosphere is mostly nitrogen, then a big chunk of oxygen. Now that carbon dioxide number probably sounds pretty small, and it is compared to what it used to be, but it is rising very, very slowly, but it is having an effect. So let's just have a think about where the atmosphere started. So I said for the last 200 million years it hasn't changed much. Now that might sound like a long time, but in terms of the life of the planet, it's not really. So we need to go back 4 billion years to when the Earth first formed, and its atmosphere looked like this. It was mostly carbon dioxide with a little bit of methane and then some ammonia. So life as we know it could not breathe that in. That's pretty toxic and deadly. Then, about 2.5 billion years ago, the amount of carbon dioxide was beginning to reduce, as you can see. So there's much less carbon dioxide. We see the beginnings of nitrogen being formed and oxygen, and there is less ammonia and methane. And that process keeps going on until we get to where we are now. So mostly nitrogen with a bit of oxygen, and then some other little bits floating around in there. So, what caused these changes? Well, way back 3.5 billion years ago, there was a lot of volcanic activity. Now, volcanoes, when they degas, so they let gases out, they release CO2, methane, and ammonia, which were the gases that made up the atmosphere. They also release water vapor. Now, as the Earth cooled down after forming, that water vapor is what then went on to form the oceans. So, what caused the change in the atmosphere was the emergence of plant life. So, green plants take in the CO2 and gave out oxygen. Some of the carbon from the CO2 also got locked up in the rocks, so it was just stored away in the rocks and as fossils. And then the methane and ammonia reacted with the oxygen and in the process release nitrogen. So getting a bit closer to modern day, this process kept going on and we ended up with the amount of oxygens and nitrogens that we had. But really importantly, some of the oxygen was converted into ozone, which forms in the upper atmosphere, and the ozone is really important because it blocks UV rays from reaching all the way to the surface of the Earth, and it's that allowed the formation of new life forms, new complex life forms, such as eventually us. Now, you just need to know the key steps in this one. It's not as bad as it seems. I know there's a lot there, but I have faith in you all. You'll be able to remember it. So that's the evolution of the atmosphere. So we need to know what's going on with the atmosphere at the moment. And one of the big gases that is causing us problems, as I mentioned earlier, is CO2. So we need to know how the CO2 gets into the air and how it leaves the air. So, as I mentioned earlier, the CO2 can leave the atmosphere when it's absorbed by plants. And they use it for photosynthesis, and that's how they make the carbohydrates, fats, and proteins. So they take the CO2 in. The plants do also release some CO2 back because they do respiration, the same as we do. And respiration being the process where we use oxygen to release energy from our food. So as well as taking in CO2, the plants release some as well. The plants then get eaten by animals, and those animals can get eaten by other animals. So the carbon has moved from the plants into the animals. And the animals then release that that CO2 into the atmosphere when they respire. Another way that we're letting CO2 into the atmosphere, as I'm sure you're all aware, is by burning fossil fuels. So I said earlier that some of the carbon got stored in the rocks, in the sedimentary rocks and fossils. So when we then burn those fossil fuels, we release that CO2 back into the atmosphere. Excuse me. So some more pollutants, and where do they come from? Carbon monoxide, we already know, comes from incomplete combustion. Sulfur dioxide, I've mentioned it a couple times now. The problem with sulfur dioxide is it causes acid rain, and that can kill aquatic life. It can damage buildings, particularly those made of limestone. It can also corrode metals, and it comes from burning fuels that contain sulfur. Now, we do try very hard not to do this anymore. Petrol is called low sulfur petrol, and the coal that is burned in our power stations is low sulfur coal, or there are traps that take the sulfur dioxide out after it's been burnt, but it is a problem still. And the other one is oxides of nitrogen. So when nitrogen bonds with oxygen, it can do it in a couple of different ways. And this causes acid rain as well, but it can also cause smog. So I've got a lovely picture of a city here. Bright, clear blue sky up here, but hanging around the city is this horrible smog. And this is all formed by the nitrogen oxides. Pretty nasty. And these are formed by the heat from car engines makes the nitrogen and the oxygen in the air react, and that's where the nitrogen oxides come from. So the next thing we need to know is how we can reduce the amount of pollution we get from vehicles. Some of them are pretty easy things. Running smaller, cleaner cars, so newer cars are less polluting than old ones. Hybrid cars, because if you're using electricity, you're not going to be having that hot engine, which is going to create those nitrogen oxides, and then there's no sulfur in the petrol, or there's no petrol, so there won't be any sulfur that you make sulfur dioxide. Biodiesel is a slightly cleaner version. There's definitely no sulfur in that, but it's not a perfect answer. So biodiesel is just diesel that's been made by using plants rather than from crude oil. Now the important one is to make sure that your car has a catalytic converter. Now all cars are pretty much fitted with these as standard, because otherwise it's very hard to pass your MOT. Now what a catalytic converter does is it takes carbon monoxide and oxygen and nitrogen oxide, that should say, and it converts them into carbon dioxide and nitrogen. So we get 2CO plus 2NO, which goes to nitrogen, which is just atmospheric nitrogen, and 2 lots of carbon dioxide. So that should say nitrogen oxide there. Obviously a little typo on my mistake, but hopefully, because I've made a mistake, you'll just remember it all the better. So what this catalytic converter is doing is it's taking toxic carbon monoxide and our acid rain causing nitrogen oxide, and it's converting them into harmless nitrogen. That's just the nitrogen that's in the atmosphere, and carbon dioxide. And carbon dioxide is a problem, but it's less of a problem than these two. And our final way we can reduce pollution is using public transport. If we're burning less fuel, we're going to release less pollutants. So that's the clean air topic. Not too terrible, just a few facts to remember with this one really, rather than anything difficult. You just got to find a way to remember the processes for this one. So remember, any questions, don't forget to ask, and I will see you in class.